All right, so let's take a look at this question here. First thing, as always, we're going to begin with the question sentence. And I know I sound like a broken record when I say it, but it's too important. So right here, we want to know what her final elevation is. So with that said, everybody, when we think about what's going on, well, we're talking about a hiker, and this hiker starts at a certain elevation, a certain place. So if we're kind of visualizing this, kind of like a mountain range, something like that, we can say that the hiker starts at a certain elevation, let's say 3,200 feet. From there, it says she climbs upward. So we can go ahead and just mark this right over here. So we can go ahead and say that we can start at any point, and then we climb upward. Everybody, when I think about that, she climbs upward. Am I going to draw an arrow up or down? Simply put, the direction I'm going to choose is going to be up. And so with that, that's what this describes, going up. And then everybody help me out real quick. What does this keyword here mean? It says the hiker then descends at this rate for this time. But what does that keyword here, descend? What does that mean? Yeah, that means going down. Yeah, and we count that as negative. So let me highlight that here in purple. And then let's mark that out. And there we go. So from whatever this point is, we'll then be going down. So it looks like what we have going on here is we start at this elevation, we add some distance, and then we take some distance away. Everyone, before we continue, does that make general sense to you? Again, we started at this elevation, then we climbed up. Okay, cool, going up. And then we descend, so bam, going down. And what we're trying to achieve here is, hey, where's that final spot at? So let's check that out here. So we have the 3,200 feet that we start off at. And we'll go ahead and add what happens in the climb. Everyone, to find any distance, remember that distance equals rate times time. So even though I don't have the distance of how far we climbed, we can definitely find that out. Let me go ahead and show you. So right over here, climbs upward at 600 feet per hour for 4 hours. Everyone, feet per hour, that's a rate. Hours by itself, that's time. So when we consider that, we're going to have 600 as the rate multiplied by time. Everyone, what is 600 times 4? Help me out there. Yeah, that'll be 2,400, nice and easy. And we'll write that down. We're going to add 2,400 feet because, again, we're climbing, we're going up. So we have the 3,200 plus the 2,400. But remember, we have to subtract the distance that we descend. So let's figure out what that is. It says our rate is 800 feet per hour, and we do that for 2 hours. So every hour we go down 800 feet to figure out the total distance. That's just going to be 800 multiplied by 2. So let's go ahead and show that here. 800 multiplied by 2, and that's going to give us 1,600 feet. And there we are. So now what we're going to do is just bring everything together, understanding that the climb is where we'll add, and then descending is where we will subtract. As long as we understand that, what ascending and descending, or climbing and dropping, as long as we know what those mean, we're good to go. 3,200 plus 2,400 gives us 5,600. And then from there, we subtract the 1,600 feet, and that's going to be very straightforward because 5,600 minus 1,600 is 4,000. And there we go. Our correct answer here is going to be answer choice B, 4,000 feet. And we should feel pretty good about, again, tracking the story and then knowing what ascending versus descending means. All right, new question. So the question sentence is where we begin as always, and it says, if it holds this many cubic feet, what is its height? Okay, so that's what we're going to focus on. We're looking for the height of the object in discussion. We're not looking for volume. We're not looking for area. We're looking for the height. And what we're given, what we're dealing with here is a rectangular box. So in this case, we see that we're given its length, its width, and we want its height. Knowing that, hearing that one more time, we have length, width, and we're looking for height. Hey, we might be dealing with volume, we might be dealing with surface area. I'm not sure yet. How I'm sure is right over here. It holds 168 cubic feet. Right there. That's what I want to pay attention to, the cubic feet. Everyone, what type of a unit is a cubic foot? Is that area, surface area, volume? Yeah, that's volume. Cubic units, that's how we know, everyone. Cubic units, that's what indicates volume. So if you take a look at the clues, take a look. We have a rectangular box, which is the same as a rectangular prism. We have the volume, we have the length, we have the width, and we're looking for the height. That right there should scream at you that we're dealing with the volume of a rectangular prism, which is length times width times height. The only difference here, is that instead of trying to multiply these three to get the volume, we actually already have it. We have the volume, and it's going to be 168. When we plug in the other values that we have, like the 6 for the length and the 4 for the width, we see that we are trying to find that height. So, to work backwards here, which is exactly what we're doing, because again, if we knew what the height was, we would multiply to get this. But now we're working backwards, and so we'll divide the 6 and the 4 out to get the height by itself. So, a couple of options. Option A, we can go ahead and multiply 6 times 4, and then we can divide. Or option B, which is my recommendation, option B, divide one of the numbers at a time. So I'm saying, hey, let's just divide out the 6 at first, and then let's divide the 4. That might be a little easier if you're trying to work your long division as quickly as you can. Because 6 going into 168, hear me out, check this out. 6 going into 168, we have twice, 2 times 6 is 12. We have 4 left over, and we drop this 8. From here, 6 goes into 48, that'll end up being 8 times. So boom, that's a clean 48, no remainder. And so there we are. When we cancel out the 6, we have 28 equals 4 times h. And now when we divide the 4 out, at the end, notice what we get. Divide the 4, divide the 4. Everybody, what is 28 divided by 4? That's going to leave us, that's going to leave us with 7. And there we go. That is our height, 7 feet in this case. And that's going to give us answer choice B. But again, before I continue, I want to mention that we could have absolutely done 6 times 4, which is 24. But you would have done a little bit of guessing and checking to get that 7 for 168. We also could have divided by 4 first. 4 is just dividing by 2 twice. 168 will turn into 84. And then from 84 will turn into 42. 42 divided by the remaining 6 still gives us 7. So again, I just wanted to point out a couple of different ways we could have done that. But nonetheless, this was a volume problem where we had to work backwards.